Okay. The next topic is known as shearing stress. And it is one of the toughest topic, okay, in engineering mechanics, or we call it in solid mechanics. But I make it in such a way that it's easy to understand, and how I get it to ensure that it's easy to understand at your end is I've done a lot of examples. I have made rules that you don't see from textbook that you have to follow. Okay, and I will show you how I come about deriving all these rules. Okay, and all these rules are derived, or they make are derived mathematically. Okay, so what is shearing stress? Okay, so let's understand the concept of shearing stress. So shearing stress, okay, shearing stress are stresses acting parallel to the surface. Okay, so I'm going to sketch out an element. Okay, so we have, let's look at 2D first. So this is our axis. Okay, so this is X, and this is Y. We draw our element. Okay, and over here, our shear stress, right? So you can see that this is acting parallel to the, so you can see this arrow over here is acting parallel to the surface. And this is what I call shear, right? The intersecting plane is on the x-axis. The stress is acting in the y direction. Okay. So I will draw, and okay, let me define what do I mean by the x. So the x is the plane intersecting the x-axis of the transformation. So what this means is the yellow plane that I've drawn. Okay, so this yellow plane that I'm highlighting now. If you bring to the transformation, right? So that is a transformation. It will intersect the x-axis. Yes or no? So this is the same plane, which I'm going to highlight in yellow. Okay. So the first subscript is the plane intersecting the x-axis of the transformation. The next one, the y over here, detect the shear stress direction. So the shear stress direction is this arrow over here, right? So it's pointing vertically upwards, is on the y-axis, okay, along the y-axis, okay. So usually, not usually, always, when you have a shear xy, you have to have a counter shear. Okay, so you have this shear over here, and this is what we call our shear. The intersecting plane now is the blue line I'm going to draw. and it intersects the y-axis, and the shear stress is intersecting the x. Okay? And to complete the shear force of the element, you have to draw likewise. Okay, to complete the element. Okay, but we only focus on the yellow plane and the blue plane. Okay, so this is what we call positive shear. Now, don't worry about whether is it positive or negative shear. Yeah, it's just an introduction over here. So this is what we call positive shear. Okay. Then if I have to construct negative shear, right, I'll draw the same thing. I'll draw the same element. Okay. So negative shear, again, you only need to whether positive is all, you have to these two surface control it. Okay. So for negative shear, this is again your shear. Intersecting plane is y, direction is in the x, and this is shear x, y. Then again, you have to draw the other arrows. So this is what we call negative shear. Okay. So I just introduced to you what is positive and negative shear. Later on, when we deal with Mohs circle, this is very critical. For now, it's just an introduction. Okay. So now you understand. Now you can visualize where the shear stress is acting on which plane. Okay. Now in real life, it's not 2D. It's going to be 3D. So now I'm going to introduce you to a 3D element now. Okay. So this is X, Y, and you have your Z. So now we're going to draw a cube. Right? So we are going to sketch. So you will have 6 shear stresses. 6 directions. So I'm going to do the first one. So based on the intersecting plane, right, this surface will intersect the x axis, and it's in the y direction, right? And then this will shear y x. Okay. Then I'm going to draw over here, right? So this is shear. Oops, not properly drawn. To apologize. So we have the shear in this direction. So the intersecting plane is x. The plane intersect the x-axis. The directions is in the z. So you will have a counter down here. So this is shear z, right? This plane will intersect the z-axis, and it's in on x. And the third one, this is shear. The intersecting plane is y, and then the shear stress direction is in the z. And then you have a counter shear z, and then this is y. Okay. So in shearing stress configuration, right? In shearing stress configuration, and it's always true for the condition of equilibrium. Okay. Shear xy is equal to shear yx. Shear xz is equal to shear zx. And shear yz must be equal to shear zy. Okay. This condition is always true. Okay. Now, how does the failure in shear occur? Right? You have to visualize how the failure in shear occurs first, then you can appreciate shearing stress. Okay. So now we are going to look in failure by shear force. Okay, we're going to look at failure in shear force. So I'm going to sketch out a cantilever beam. So this is our cantilever beam. And I'm going to sketch our cantilever beam such that it has layers. Okay. Such that it has layers. So 1, 2. Yeah. This is just a schematics. Okay, this is just a schematics. Okay, so let me draw them properly. Okay, so we have, come on, today my pencil is not behaving. It's okay. Okay. So this layer, okay, so when this layer, all this layer, can you imagine like a deck of cards they can slide, are able to slide. Okay, right? So imagine like it's a deck of cards. Then we will have a shear force. Okay, we will have a shear force over here. And this is what we call V. Right? V over here define our shear force. This is our shear force. Right. So when the shear force is applied, okay, the next part I'm going to do is the deformation pattern. Okay, so the next one exactly on the side is deformation pattern. And you guys know how it will deform. And before I go on, I will draw our transformation. That this is X, Y. This is our rotation in our Z. Okay. So I'm going to now sketch our deformation pattern. And the deformation will look like this. Exaggerated. Okay. So hopefully this works. Right. So now we have a deformation that looks like this. Right. So now all this, right, becomes, you know what? Yeah, I'll not waste too much time drawing. Okay, so that is our deformation pattern. Okay, so by looking at this structure over here on the left hand side, right, we know that the shear stress is acting in this direction, right? So if we were to use our same definition, this is shear X, Y, right? And shear XY will induce, it will have equilibrium Right, let me use a different color for this. I do apologize. So not everything look the same.